Hi everyone, thank you very much for the invitation to be here today. It's a real pleasure for me. My name is Álvaro Soto. I work in the National Center for AI and also at Catholic University. And today I will tell you about my vision of some important steps that have been happening in the AI scenario. So this is a short talk, and I had mostly two messages for you. Yeah. The first message is related about the present state of the art in AI. So I would like to give you my view of what are the real two main technology behind the current revolution in artificial intelligence. This first revolution, it happens around 2012, and it's based on some technique that allow us to implement memory, what I call memory-based machines. And the second revolution is very recently, it's 2020, and it's related to some machines that are showing some reasoning abilities. So that will be the first part of the talk. And the second one, I will try to give you my view, according to some impact in the near future. Now, this is changing very, very rapidly, but at least I had some insight about what I believe will be the impact in the near future. And that will be mostly a new way to access knowledge, and also a new way to build machines with all these technologies. Yeah. So that's the agenda. So let's start with the first revolution. These memory-based machines. And what is behind these memory-based machines? A lot of work, but there is a landmark paper about this. This is a paper by Jeffrey Hinton and collaborators, and it appears in 2012. And what they propose is what today is called deep learning. And deep learning mostly implement an associative memory. So what is an associative memory? So that's the question. So an associative memory works like this. You had a pattern, and that pattern could be an image, or could be a text, or could be a piece of video, could be an audio, And what an associative memory do is that it transforms the pattern in a memory address. That's what it does. You had the pattern, and the pattern is transformed in a memory address. So what is this important? Because when you have the pattern, you go to the memory address, and in your memory, you put information about the pattern. For example, it is an elephant, it is alive, it had to eat, it lived in, all information that you want there. And this is very powerful, because, for example, if you are seeing the world, what you see there is really a memory address. So we are kind of, humans also seems to be that we work in the same way for our pattern recognition abilities. So we are kind of seeing memory addresses everywhere. And the memory address has a straight connection to the information about that pattern. So this is very important, because otherwise we have the pattern and we need to search in all our memory. What is this? What is this? Oh, elephant. And that's very slow. But if you have direct connection to the memory address, you go directly to the place where you have information about that pattern. So deep learning works that way. What you see here is it's the architecture actually in that paper in the 2012. And this is a deep learning, so all these are neurons, layers of neurons. But the thing is that in this case, in the input to this transformation is an image. So you have here an image. And if you track this transformation, you can get to this place where you have 40,096 numbers. It's a vector. And to train the neurons connection, you had a lot of data, millions of data. And look at this. This is an experiment that I did. I put this image here. I took this vector. And then I searched using Euclidean distance from these millions of images, what are the closest images in that space, in this 40,096 dimension vector. And look what appears, these ones. And Well, we see that, oh, well, or elephants, But look at this, the appearance, how it looks. This elephant is very different to this one, or maybe to this one, Different pose, different background, different colors, Different parts of the body are occluded or not occluded, but besides that, this is mapping to the same memory address. All these images are to the same closest memory address there. So this is kind of an associative memory. So this is very powerful. And what is this so relevant? This is relevant because, this doesn't look that way, but before this, we had, before this deep learning, we had our relational databases where we can ask a computer, for example, if you had all your information in your ERP organized, you can ask, for example, what are the salaries of that people, how are the sales of that part of my company, and the computer, with the technology, with these relational databases, and you ask this in SQL, that is the language that the computer understands for that, it will answer. But if you show to a computer a question like this, computer, what's going on here? Before this technology, the computer will say, no idea. I don't understand this information. I understand this information, but not this one. But we are full of this kind of information. Go to internet, text, videos, audios. We didn't have technology to mine that information, but now we have one technology. So is the relevance of this. So this doesn't look way, but now the computer can see the world like this, a cup, a table or whatever. And this is also for text, for audio, for videos. So very powerful technology. So that was the first revolution. So now I will tell you about the second revolution, that is very recently. This is a resonance-based machine. So this was a paper that appeared 2020 in December in a conference that called New RIPS, and it was by OpenAI. What OpenAI did is that these kind of same models, most people were working, this is time, and this is the size of the parameters. You are mostly a statistician, you know about parameters. So if I tell you I had a model with 5,000 parameters, you say, well, this is a big model. But look at this. This is 175,000 millions, billions in 1,075 billion parameters. So it's a monster. So most people were working in this size of the model, and now they kind of say, what happens if we push this several times and we go to that kind of size? And the thing is that when you do that, it emerge new properties, not just an associative memory, but also some reasoning abilities. And that is the new revolution. Now we have a machine that doesn't have only the memory, associative memory skills, but also has some reasoning. So new revolution. And they use a lot of data to train this because you had a lot of parameters to fit. You need a lot of data. In this case, it was around 2,025 billion words. All the text of internet, books, and a lot of data. So what properties emerge when you kind of put this model in size and scale? Things like this. For example, if this doesn't look good actually. Oh yeah. Okay. If you ask one of these models, for example, the ChatGPT, and you ask, the input to the model is a text like this one. In our garage, we had a Boringo that my father drives to every day. No, this is not right. Oh, this is right. So GPT-3, that's the model in this paper. So this is the input. I explained something like a Boringo is a car with very fast acceleration. And I asked to the model, write an example that used this new word. So you cannot use memory because this is a new word. You didn't see this word before. You cannot use an associative memory. So the model is good enough so the output is a correct sentence using this word, just with the definition. So that's another skill. It's no associative memory. And that emerges when you push the model to this size. Yeah? This is the same paper, 2020. So I will give you another example. Oh, this doesn't look anyway. Well, this will look well. So this will be the input to this model, one of these huge, monster model. You input the image to the model, and you input this instruction or this text. And the text asks the model, write a conversation between these two animals. And what I will show you that is the output of that model when you enter this information, this image, this text. And it's this. This is very recently, just this year. This is the text that the model output. So he said, cat, dog, cat. Well, good, no? But nothing here said explicitly that in the image there is a cat and the dog, so that's good. And the cat asked this, hey dog, can I ride on your back? So in somewhere in this monster model, it has some representation of this, because that's not explicitly there. No? It's somewhere in the model. So the model can set that this is something relevant for that instruction. Can I ride on your back? And the dog said, okay, sure, why not? And the cat said, I'm tired of walking in the snow. So there's a lot of understanding of what happened in that image. And it's somewhere in this model inside because it's able to output this. It knows about, it's not good to walk in the snow. One gets tired when they walk in the snow. It's good to be, look at this, when I am on top of the car, I'm not walking in the snow. I'm not walking in the snow. That's not trivial. The way that we understand the world is not trivial. That's the reason why artificial intelligence has been so long without good results. But now, well, this is a way to do it. And this is a really huge revolution. Because now we have a new technology, it can able to store knowledge. When you train this with these huge amounts of data, billions of words, it's able to store in somewhere of these billion of parameters knowledge about what is in the input data that I use for training. And then I can use that knowledge. This is a new way to access knowledge that we revolutionize our society in the next year. This is very, very powerful. So, summary of this first part. Powerful pattern recognition abilities through effective associative memories. Works very well. And then we had also some powerful reasoning abilities, but still unstable. This property is an emerging property of the size. Why it happens? When, where, when it works, when it's not, it's something that still needs some more research. When you probably, if you can interact with ChatGPT, sometimes it hallucinates things, and had bias, had different problems. That is because it's an emerging property. Okay, so this is very good, worked very well. This is something very good. Still need more research, but still provide application. So the second part of the talk, I will tell you about what I believe there are some implications of this technology. First, I believe, is a new way to access knowledge. So far, we have been accessing information, but now we will access knowledge. That's a huge difference. So in the 80s, I was a student in the university. In that time, my only way to access knowledge, I was in the university, is going to the class, or otherwise go to the library to find a book that usually was very difficult to find, because my classmate also wanted the same book, so it was not easy. No internet. 80s, no internet. There was another way. This was, maybe I can ask an advantage classmate that knows, but no. So in the 90s, that was kind of more easy. Today, if you want to learn about AI, go to the web and ask. There was a video, so a lot of information about it. Maybe too much. Difficult to find the one that is really good. Yeah, but it was good. We had a new way to access information. Yeah, but it was slow. If I want to learn about AI, it will show me. It will give me some papers. It will take me a while to really read those papers and understand what is in those papers. Maybe for you, a statistician has probably the same problems. So now we had a new technology. We had these GPT models, like GPT chat. If we put all the papers about the statistics to this model, then I can ask directly my question to this model about things that are interesting to me. How I do this with this statistics model or whatever. And the model will give you useful information. That is really a new paradigm, a new way to us acknowledge that will make each of us more efficient. Very, very, and that will happen in the next years. This is ready. This is no research. This is no science fiction. This is working. The technology is not a secret formula. It's not like OpenAI, like the Coca-Cola. No, they had only the formula. No, this is something that is known by the people in the community of AI. The type of model. Well, this should be one email. Oh, no good. Well, it was an example. I usually had a hard time when I tried to search for all mails. I use Gmail, and I go and ask for an email. And usually, I kind of send me a bunch of emails. Say, I am trying to search an email. I wrote it 2 weeks ago. It was to my daughter. It was about his trip, her trip to the beach. Nothing. Thousands of things. With this technology, that would be very trivial. It would say, this mail. Much more efficient. So, this doesn't work. No. Well, that was the first. It was enough to explain my point. The second was, maybe it's not very interesting to you, but I'm related to that too, is we will be able to build new machines. All our current machines are very dumb. The main example that are very dumb is that they are full of buttons. Even our kind of intelligent phones, if you turn it on, so main interface buttons. Why so many buttons? Because the machine doesn't know what to do. I had to do this, do this, do this, do this. With this technology, the machine will be more autonomous. So we had new ways to build machines. For example, robots. I co-founded a company, Siberi, and this is a Chilean company. We build robots for retail stores, and at this point, we had more than 200 robots. They will operate tonight in US, in Germany, in Australia, in Chile. Next year, we will have some robot in Japan. That will be very good for me. We're sending robot to Japan from Chile. That was my second part of the talk. So the summary is huge technological revolution, new scenario to access knowledge. This is the short term. I don't know, maybe 10 years it will be new things. And this is very important. We got a new cognitive tool. We had a lot of tools, but this is a cognitive tool. And in a partnership with humans, we will make each of us more efficient to boost productivity, to create business value. And that will be very soon. So be better prepared for this. Thank you very much.